Hello students, today we are going to discuss electrochemistry. As you have seen, yesterday we did the basic concept of electrochemistry, in which we have seen two types of changes, primary as well as secondary changes. Now today we are going to discuss about Faraday's law. Keep in mind, Faraday, it gives a quantitative relationship between the amount of the current passed through the electrolyte to the amount of substance liberated or deposited at their respective electrodes. So we have two Faraday's law. Let us discuss first law. Faraday's first law. Faraday's first law simply states the amount of the substance liberated or deposited at their respective electrodes is directly proportional to the amount of charge flowing through the circuit or the amount of electricity passed through the circuit. We know when we did electrolysis process, we have cathode and anode. When electrolysis process is being carried out, here positive ion, whereas here negative ions, they get neutralized. So during the electrolysis, the amount of the substance liberated or deposited at their respective electrodes is directly proportional to the amount of electricity passed through it. So Faraday's first law. Amount, that is W, we say amount of the substance liberated or deposited at the respective electrodes is directly proportional to the amount of charge passing through the electrolyte, that is charge Q. So W is equals to, when we remove the proportion sign, we have to write a constant, that is Z. Z is called electrochemical constant. So W equal to Z into Q. Q be the amount of charge passing through the electrolyte during electrolysis process. Now, as we all know, Q upon P is equal to I. I means current. So Q is equal to I into T. Put this value in W equal to ZQ. It will be Z into I into T. That is W equals to Z I T. T be the time for which the current is passed through the electrolyte. I amount of current, Z is electrochemical constant. Now the value of Z is equal to E upon 96500. 96500 is called Faraday constant. So F 96500 coulomb is called Faraday's constant. Now we have written here E. What is the meaning of E? E means equivalent mass, where E is known as equivalent mass of the electrolyte which is being used. Now we just substitute the value. How to calculate equivalent mass? E equivalent mass is equal to n factor into, we know that equivalent mass is equal to molar mass upon n factor. I'm just going to erase it. So equivalent mass is equal to molar mass divided by n factor. I hope you all know what is the meaning of n factor that you have done in class 11. Let us discuss how to calculate n factor. for an acid, N factor is equal to basicity of an acid. Basicity means number of replaceable hydrogen ions. This is the basicity of an acid, that is N factor for an acid. Let's take a simple example. Sulfuric acid. It has two replaceable hydrogen, so we say N factor for sulfuric acid is 2. If we take phosphoric acid H3PO4, then we say its N factor is equals to 3. Why? Because it has 3 replaceable hydrogen atom from the formula. Similarly, we move towards N factor for a base. For base, N factor is acidity of base, means number of replaceable OH ions. For example, if we say calcium hydroxide, then we say N factor will be 2 because it has 2 OH. Sodium hydroxide, we say its N factor is equals to 1. Now, this is second. Third, N factor for a salt. Let's take a salt. We know a salt contains 2 parts, positive as well as negative part. So N factor for an acid is equal to positive charge on cation. For example, if we take magnesium chloride, then positive charge on the magnesium is +2. We say the N factor for magnesium chloride salt is +2. Now, N factor for an element is equal to valency of the element, means the number of electrons required to complete the outermost shell. If we say oxygen, N factor for oxygen is taken as 2. We have to take magnitude because oxygen has valency 2. It is -2, but we take the magnitude +2. Similarly, N factor for an ion is equal to magnitude of charge on ion. Keep in mind, magnitude means N factor must be taken positive. So when we take an ion, then its N factor will be charge on the ion. If it's negative, we have to change into plus. We have to take plus sign. Now last one is N factor for a redox reaction. That means the reaction in which oxidation and reduction takes place. That is number of N factor for a redox reaction is equal to number of electrons transferred. So, how many electrons are being transferred in a redox reaction? That represent N factor. So, now we can easily find the value of Z. So, Z is equal to molar mass divided by N factor into 96500. This is the value of Z. and Faraday law W equals to ZIT. First we calculate the value of Z, then we substitute the value here. We can easily calculate the amount of the substance liberated or deposited at their respective electrodes. This is Faraday's first law. Now, let us move towards Faraday's second law. Faraday's second law says that if the same amount of charge is passed through the cells, electrolytic cells, connected in series, then the ratio of the amount of the substances liberated or deposited at their respective electrodes is directly proportional to their equivalent masses. It means W1 upon W2 is equals to E1 upon E2. So that is Faraday's second law. So Faraday's second law, it simply states when the same amount of electricity is passed through different electrolytes connected in series, then the amount of the substance liberated or deposited at their respective electrodes is directly proportional to their equivalent masses. It means W1 upon W2 should be equals to E1 upon E2. It's very simple to identify. Let us consider we take two different electrolytic cells. These are two electrodes. Here we have one electrolyte and here we are taking the other electrolyte. It simply states when the same amount of charge or current passes through different electrolytes connected in series, then the amount of the substance liberated or deposited at their respective electrodes is directly proportional to their equivalent masses. E1 and E2 are the equivalent masses. How? We know W1 is equal to, from Faraday's first law, Z into I into T, or it can be written as E1 upon 96500 into I into T. Similarly, W2 is equal to E2 upon 96500 into I into T. Here I into T remains the same because same amount of current is passed through two electrolytes for the same interval of time connected in series. So when we divide, cancel, this cancel. So W1 upon W2 is equals to E1 upon E2. This is the Faraday's second law. Now we are going to discuss few numericals based on Faraday's laws. Now you can see a numerical. It says when a current of 0.75 ampere is passed through copper sulfate solution. Now keep in mind copper sulfate is a salt. We know the N factor for copper sulfate will be 2. Why? Because copper sulfate is copper 2. It gains 2 electrons, get converted to copper. Now N is equal to 2. For 25 minutes, time is in minute. It must be in seconds. 0.369 gram of copper was deposited. It means W is 0.369. Now we write the formula. W is equals to ZIT. What is W given? 0.369 equals to Z is molar mass upon N factor into 96500 into I into T. So 0.369 equals to molar mass, which we need to calculate, upon N factor. N is 2 into 96500 into current. What is the value of current? 0.75. And what is the time given? 25 minutes. 25 into 60. The minutes has been changed into seconds. So now cross multiply. Molar mass will be 2 into 96500 multiplied with 0.3694 divided by 0.75 into 25 into 60. So when we solve this numerical, the value is coming around 63.5 gram. That is the molar mass of copper when 0.75 ampere current is passed through the electrolyte, and the amount of substance, amount of copper deposited is 0.369. Here it may be 63.5. Just do it. It's around 63.3. Solve it and check. Let us do another numerical. Here is a question. A solution of copper sulfate is electrolyzed for 10 minutes. Time 10 minutes with 1.5 ampere current. What is the mass of copper deposited? We have to find the mass of the copper deposited at its respective electrodes when we pass a current of 1.5 ampere for 10 minutes. We know the formula. According to Faraday's first law, W is equal to ZIT. Z is molar mass upon N factor into 96500 into I into T. We need to calculate W. What is the molar mass of copper given? That is 63.5 divided by N factor. We know the N factor for copper is 2 because copper sulfate, or we can say that copper has valency +2. So N factor is 2 into 96500 multiplied with I. What is the value of current? 1.5 ampere. And time is 10 minutes. Of course, minutes should be changed into seconds. 10 into 60. So we solve 1, 1, 1, 1. We get 63.5 into 1.5 divided by 2 into 965. So when we solve, the value of W after solving is coming to be 0.296 gram. That is the answer. It means the amount of the copper which is deposited at its respective electrode is 0.296 gram. This is the way how to solve. Now you are requested to just read Faraday's law, try to solve the numericals based on the Faraday's law. Tomorrow we will proceed further. Till the time, keep practicing these numericals. Thank you.